uses red cabbage as a pH indicator. So before we start, we're going to introduce ourselves first. So my name is Alicia Effendi, binti Lutfi Effendi.
My name is Sharifah Patricia binti Idris.
My name is Yong Chong-Hui.
My name is Nishaza Amira binti Amira. My name is Samara binti Amira.
All substances in our daily lives are classified as either acids or bases. Think of acids and bases as opposites. Acids have a low pH and bases have a high pH. For reference, water is a neutral because it has a pH of 7 on a scale of 0 to 14. We can tell if a substance is an acid or a base by means of an indicator. An indicator is typically a chemical that changes color if it comes in contact with an acid or a base. Red cabbage juice is considered to be an indicator because it shows us something about the chemical composition of other substances. Therefore, our group has made a pH indicator by using red cabbage. Red cabbage contains a water-soluble pigment called anthocyanin that changes color when it is mixed with an acid or a base. The chart below can help us figure out how acidic or basic the test liquids are. Based on the chart, the red cabbage juice turns red when it mixes with something acidic and turns green when it mixes with something basic. The pigment turns red in acidic environments with a pH less than 7, and the pigment turns bluish-green in alkaline or basic environments with a pH greater than 7.
Before we start our experiment, we will need to prepare some materials and equipment. First, we will have blender to blend the red cabbage, strainer to filter out the leaf of red cabbage, pre-cut red cabbage to act as the acid and base indicator, 900 ml of water mixed with red cabbage, 1 liter large container to store the red cabbage juice, 10 cups to put all liquid substances, 10 spoons to stir the mixture of liquid substances and red cabbage juice. Last is measuring cup to measure the liquid substances. Next, we need to prepare ingredients to make liquid substances to test. We will have water, lemon, tomato, milk, black coffee, baking soda, dish soap, vinegar, toothpaste, and bleach.
Prepare materials and apparatus as stated. In a blender, add 900 ml of water and red cabbage. Close the lid of the blender and blend it for 40 seconds at high power. As a precaution, wear a lab coat to avoid stains. Once the cabbage has finished blending, filter out the leaves inside the mixture with a strainer and pour the red cabbage juice into 1 liter large container. Next, label each cup with each of the liquids. Pour 100 ml of each individual liquid into its respective cup except for solid substances and mix it well. For solid substances, add 3 tablespoons of solid substance into 100 ml of water. Pour 50 ml of cabbage juice into each of the cups. Observe the color changes and record the table. Using the first measuring jar, measure 100 ml of dish soap. Pour the dish soap from earlier into a container that was labeled as dish soap. Measure 50 ml of the juice extracted from red cabbage. Pour the solution into the same container containing dish soap. Using a spoon, stir the solution together and observe the color changes. Cut the lemon into half using a knife. Using a lemon juice extractor, extract the lemon juice. Repeat step 1 till 2 if necessary until it has reached to 100 ml. Pour the lemon juice in the measuring jar into a container that was labeled as lemon juice. Pour the juice from earlier. Then add 50 ml of juice that was extracted from red cabbage into the same container. Using a spoon, stir the solution and observe the color changes.
Next, measure 100 ml of water using a measuring cup. Put 3 tablespoons of toothpaste in the measuring cup and stir it. Pour the solution into the plastic cup. Pour 50 ml of red cabbage juice and observe the color changes to a blue, which indicates that toothpaste is alkaline. Next substance is baking soda. Measure 100 ml of water using a measuring cup. Put 3 tablespoons of baking soda in the measuring cup and stir it. Pour the solution into the plastic cup. Just like before, pour 50 ml of red cabbage juice and observe the color changes to a blue, which indicates that baking soda is alkaline.
Next, we will be testing vinegar. Measure and pour 100 ml of vinegar into a plastic cup. It is advisable to opt for vinegar without any additional additives or ingredients to get better results. After that, proceed to pour 50 ml of red cabbage juice and observe the color changes to a shade of pink, indicating that vinegar is acidic. Then, bleach will be the next test substance. Measure 100 ml of bleach using the measuring cup and pour it into a plastic cup. Just like before, pour in 50 ml of red cabbage juice and observe the color changes to a greenish yellow, which indicates that bleach is alkaline.
Next, we will be testing the pH level of milk. For this, pour 100 ml of milk into a measuring cup. Pour the milk into its respective cup. After that, pour 50 ml of red cabbage juice into the cup and observe the color change. As you can see, the color of the milk changed from white to light purple, indicating that the pH of the milk is neutral. Moving on and using the same method, pour 100 ml of boiled water into a measuring cup. Pour the boiled water into its respective cup. After that, pour 50 ml of red cabbage juice into the cup and observe the color change. The color of boiled water will change into a vibrant purple, indicating that boiled water is neutral.
Our non-liquid substance is black coffee. Pour 100 ml of black coffee into a cup. And then pour 50 ml of red cabbage juice into the black coffee. Stir the mixture with a spoon. A violet color will appear. Our last liquid substance is tomato juice. Cut the tomato into a half and squeeze it. Pour 100 ml of tomato juice into a cup. And then pour 50 ml of red cabbage juice. Stir the mixture with a spoon. A pink color will appear.
Acidic solution donates hydrogen ions. When red cabbage juice is added into an acidic solution, there will be an obvious color change. The color change that can be observed varies between bright red to violet. The pH value of acid varies from 2 to 6. Some examples of acidic solutions in this experiment include lemon juice with pH value of 2, it will change color to red. White vinegar with pH value of 3 and change to pink. Tomato juice with pH value of 4 and it will change to pink. Black coffee with pH value of 5 and it will change to violet. A neutral solution is when a solution is neither acidic or basic, and the color of red cabbage juice will remain the same when it is added into a neutral solution. Examples of neutral test substances in this experiment include milk with pH value of 6.7, it will change to violet, and boiled water with pH value of 7 will be purple. Moreover, a basic solution which is alkaline accepts hydrogen ions. When red cabbage juice is added into a basic solution, the color change may vary between bluish purple to greenish yellow. The pH value of base varies from 8 to 14. Some examples of base solutions in this experiment include baking soda with pH value of 9, it will change to blue. Toothpaste with pH value of 10 and it will change to blue. Dish soap with pH value of 10, it will change to bluish purple. Bleach with pH value of 12, it will change to greenish yellow. Red cabbage was used as an indicator in this experiment because it contains a chemical called endocyanin. This pigment is a natural acid-base indicator. It is bluish purple in neutral substances like plain water. When an acid like lemon juice gets in the water, a reaction makes the indicator molecule change shape and it looks pink or red. When a base gets in the water, a different reaction happens that changes the indicator molecule and it looks green or yellow. Strong acid means an acid that ionizes completely in water to produce high concentration of hydrogen ions, which for example in this experiment, we can deduct that lemon juice is the strongest acid found in this experiment. Weak acid means an acid that ionizes partially in water to produce low concentration of hydrogen ions. For example, in this experiment, we can deduct that black coffee is the weakest acid test. Strong alkali means an alkali that ionizes completely in water to produce a high concentration of hydroxide ions. In this case, for this experiment, the substance test that is considered strong alkali is bleach. Weak alkali means an alkali that ionizes partially in water to produce a low concentration of hydroxide ions. In this experiment, we can deduce that baking soda is amongst the weak alkali. Based on the observation of color changes after adding the red cabbage indicator, we can differentiate the difference in pH value. For example, a substance test which is lemon juice, after adding together with the red cabbage indicator will change the color of the red cabbage indicator from purple to red as it is considered as the most acidic substance. Unlike other substance tests like milk will have a slightly different color than lemon juice as the amount of acidity of the substance is not as high as the amount of acidity that can be found in the lemon juice. Lastly, when the strongest alkaline substances test, which is bleach, is mixed with the red cabbage indicator, the red cabbage indicator will change its color into a greenish yellow color, indicating that it is alkali. Unlike other substance tests like baking soda will have a closer color to lighter shade of dark blue as the alkaline pH value is not really as high as the bleach that was tested. This is because baking soda is considered as a weak alkali.
From the experiment, we can conclude that the hypothesis is accepted. When red cabbage juice is added to a solution, the color of the solution will change according to its pH level. This is because when the red cabbage juice indicator is poured into a test substance, its hydrogen ion concentration changes, causing the indicator to change its color. The pH level of acid is lower than 7, which means that it is in between 1 to 6. Acid ionizes in aqueous solution to produce hydrogen ions, whereas bases with the pH level of higher than 7, in between 8 to 14, ionizes in aqueous solution to produce hydroxide ions. Last but not least, a substance that is neutral, which means that it is neither an acid nor a base, falls under the pH level of 7. It is considered neutral due to the fact that the number of hydrogen and hydroxide ions present is equal.